is equal to its negative matrix like minus A, then it is called as a skew symmetric matrix, right. So, now we know what is a symmetric matrix and what is a skew symmetric matrix. So, here we are given x and y are two matrices whose orders are given as a 3 by 3, like it is a 3 by 3 square matrix, and they are non-zero. So, the thing here is they are no zero elements, like they are not completely zero, some of the elements definitely are non-zero, and they are skew symmetric. That means x and y are skew symmetric. That means the transpose of x is equal to negative of x and the transpose of y is equal to negative of y. Then Z is an arbitrary matrix, which is again 3 by 3 matrix and a non-zero one. It is a symmetric matrix, that is its transpose is equal to itself. Then which of the following matrices are skew symmetric? Okay. Which of the following matrices is or are, like this is R, he is not giving us a clue that one of them are. Generally if he says it is or are, then we will get a clue, right, like whether one of them are a couple of them are more than one are the solutions. Like here there can be one or more, that is the reason he said either is or are. So, you have to find out which of these matrices given here. So, this will see, this is a matrix, when you multiply y with itself and then multiply with z power 4 and then do this operation, you will get a matrix here. When you do this operations on this matrix, you will get one more matrix finally, right, and this is also a matrix and this is also a matrix. So, out of these 4 matrices, how many of them and which of them are skew symmetric is what we have to find. And we have no doubt that the multiplications are always possible here, because both of them, all the 3 of them actually are 3 by 3 matrices, and so multiplication is always possible here. Even if you transpose, you are going to get 3 by 3 matrix, and it satisfies the multiplication condition for the matrices, right. So, we have to find out how many of these 4 and what are they are skew symmetric, right. Let us see what we can do. So, as discussed, since x is a skew symmetric matrix, so x power the transpose of x is equal to minus x and the transpose of y is minus y and the transpose of z is equal to z, since z is only symmetric, it is not skew symmetric. So, what are we doing here is we are picking each one of those, like each one of the answers, each one of the options given to us in the question, and we will try to check whether it is symmetric or skew symmetric or none. That is what we will try to do. So, what is the first one here? Try to remember this. The first one here is y cube times z power 4 minus z power 4 times y cube. So, we will try to find the value of this one, like we will see what matrix it will be, whether it will be symmetric or skew symmetric. Means we will try to find whether its transpose will be negative of this, or it will be equal to itself, or it is equal to none. Let us see. So, see, this is the first one, right, y cube z power 4 y cube. So, here y cube z power 4 and z power 4 y cube. So, what happens here? Right now, since the applying the transpose properties, we already know that A minus B, the transpose of this will be equal to the transpose of A minus transpose of B, right. So, using that I am taking this transpose onto each of these products, right, each of the products. So, y cube times z power 4 transpose minus the transpose of z power 4 times y cube. Next, we know one property, right, like A times B transpose is equal to B transpose times A transpose. So, I am using that property and writing this one as z power 4 transpose, the transpose of z power 4 times transpose of y cube, transpose of y cube. Since I am treating this as a matrix A and this as a matrix B, then B transpose times A transpose, right, minus, here also use the same rule and you can write it as transpose of y cube times a transpose of z power 4, right guys. So now this one, using the exponential laws, we can write it as the transpose of z raised to the power of 4, the transpose of y raised 3 times, and then the transpose of y raised 3 times, and transpose of z raised 4 times. So we just used the exponential rules there, we didn't do anything strange, right. Now I already know that the transpose of z is equal to z itself. So the value will become z power 4 or z power 4. Next, the transpose of y power t is minus y, we already know that, and since it is a cube here, it will be minus, since the power is odd, you are raising it, multiplying it 3 times, minus times minus times minus will bring us a negative y cube here. In the same way, this one minus this y power t is again minus y, and power 3 will make it minus y cube, and this will be z power 4 because this value is directly equal to z, z power t, the transpose of z is equal to z itself, right. So z power 4. Now what can we, let us try to simplify this, okay. So this will be minus times z power 4 y cube, I multiplied these two matrices, and then this will be minus times minus is plus y cube z power 4, y cube z power 4. And what do we have here for us, like y cube z power 4 is in the first place, right, like y cube z power 4 is there. So what I will do is I will write this one as the first term of the expression. So I bring it here, means I am just interchanging the terms, I am writing them like, you know, arranging in an order. So this will be y cube z power 4 minus z power 4 y cube, z power 4 y cube. So when you look at this, like we started with y cube z power 4 minus z power 4 y cube, it's a transpose, and that one has come equal to y cube z power 4 minus z power 4 y cube. So what can we say? We can say that it is symmetric, it is not skew symmetric, it is just symmetric, because the value of the transpose of this entire matrix is equal to itself, it is not negative of it. So it is not a skew symmetric, it is simply a symmetric matrix, right. Now let us look at the second option. What is the second option? Y power 44 plus x power 44. Or x power 44 plus y power 44. So let us take that option. This is the second option which we are taking, right, x power 44 plus y power 44. We already know that x is a skew symmetric and y is also skew symmetric, right. So it is a transpose, if I want to find its transpose, if I want to find its transpose, again a plus b to the power transpose, like a plus b, the sum of a plus b's transpose we want. So a plus b whole transpose can be written as a transpose b, a transpose plus b transpose, right. So this is what we can write, a plus b transpose is B transpose. Using the same, I have written this one as x power 44, the transpose of it, plus y power 44 transpose. Using those laws of exponents, I can write it as x transpose of raised 44 times, y transpose raised 44 times. So, this is just by using simple exponential rules. Now, x power t, what is x power x transpose? X transpose is minus x, and it is raised how many times? 44 times, plus y transpose is again minus y and raised 44 times. Right, minus y raised 44 times. So, now the power is what? Even number. So, simply it becomes positive x power 44 plus positive y power 44. So, the transpose of this one is also the same itself, or else you can say itself, like x power 44 plus y power 44 transpose is a matrix which is equal to itself, which is x power 44 plus y power 44. So, we can simply say this one is also a symmetric matrix, but not skew symmetric. So, as per our question, these two are not our answers so far, right. We just need to find what we wanted to find, what are the skew symmetric matrices. Now, let us take the third option. What is the third option? X power 4 y z cube minus z cube x power 4, x power 4 z cube minus z cube x power 4, remember that. So, x power 4 z cube minus z cube x power 4, and I am trying to find its transpose. See, what are we trying to do here is just finding its transpose and checking whether it is equal to itself or it is negative, nothing else, right. Now, here again applying the same rule, you can write it as a transpose to the two different matrices. So, I am applying the transpose to these two different matrices and then applying the rule a power a b whole transpose is equal to b transpose times a transpose. I am writing this in this form, like z power t whole z transpose cube x transpose power 4 x transpose power 4 z transpose cube, right. Now, transpose of z is equal to z. So, z transpose cube is equal to z itself. So, z cube, then x transpose is what? Minus x power 4 is x power 4, because negative of x whole power 4 will be equal to x power 4 itself, because we are multiplying it even number of times, right. And then this is also is x power 4, and this will be z cube in the same way, like on the same lines like how we did here, right. But what did we start with? We started with x power 4 and z cube, and here z cube and x power 4. Remember, what is the difference between these two? Matrix multiplication is not commutative. So, that is the reason we are looking for the order, right. Now, this one I want it to be the first term, because this is my first term here. So, I bring it to the first term's place, then it will be minus. So, I am taking the minus sign common, then it will be x power 4 times z cube minus z cube times x power 4. So, what did we get? The transpose of this is equal to a negative value of the matrix. So, what can we say? We can say that this matrix is a skew symmetric matrix. The matrix x power 4 times z cube minus z cube times x power 4 is a skew symmetric matrix, right. Now, let us see our fourth option. So, C is one option which we can say, which we can mark for this question, right. A and B are not the options, C is the option. Now, the fourth option is x power 23 plus y power 23. So, again using the rule, we can write the transpose to both of them, like you can write it as x power 23 transpose plus transpose of transpose of y power 23 we can write, and then using the rules of these exponents you can bring the transpose inside. So, x transpose to the power of 23 and y transpose to the power of 23 is what we can write. Now, from this, see, x transpose is what? Minus x. So, this can be written as minus x to the power of 23 plus this can be written as minus y to the power of 23, because x and y are skew symmetric matrices. So, their transpose will be equal to negative of the matrix. And now, here this 23 is an odd number. So, what this can be written as is minus x power 23 minus y power 23. Since 23 is an odd number, the negative of it will be remain negative. So, negative x power 23 minus y power 23, and I can take minus sign common because I have a plus sign here. So, minus sign when I take common, it is x power 23 plus y power 23. So, what happened here? Like the transpose of this particular matrix x power 23 plus y power 23 has come as a value which is negative of x power 23 plus y power 23. That means this is a skew symmetric matrix. So, D is also one of our options. So, D and C are the skew symmetric matrices given in our options, and A and B are not the skew symmetric matrices, they are symmetric matrices. If the question asked about symmetric, then A and B would be your answers, right. So, C and D are the answers because we are looking for skew symmetric matrix. Okay, we are looking for skew symmetric matrix. So, those two are your answers, right. Just keep posting your comments if you have any questions. I hope this is clear so far. Let us go into the next question. Let me clear this off here. Yeah. The second question says, for a real number alpha, alpha is a real number here. Where is alpha? This is alpha here. If the system of linear equations has infinitely many solutions, then what is the value of 1 plus alpha square is the question given to us. Okay. So, how can we do this one? First thing we should know is, see, these are the system of linear equations, right. How many linear equations you can form from this? Like 3 linear equations, right. This is 1, 2 and 3 linear equations you can form, right. These are the 3 linear equations which we can form from this, and these have infinitely many. When will they have infinitely many solutions? First of all, when this type of system is given, we know, right, like this is called as the coefficient matrix. And the determinant, why do we call it as a determinant? Actually, determinant, it decides whether the system of equations have solution, one solution or many solutions or no solution, right. So, how do we do that? Like the discriminant, when the discriminant of this is not equal to 0, then the system has one unique solution. When you find the discriminant determinant of this one, the det of this one, if it is not equal to 0, then there is one solution. If this becomes 0, if this is equal to 0, then there are two cases, like either the system has infinitely many solutions or the system has no solutions. That means, the two lines are planes, whatever you take them as, the two lines are parallel or they are coinciding is what it says. So, here he says it has infinitely many solutions, which is our the second case. So, we have to equate the discriminant to 0 and find out the solution, right. So, remember one point, like the determinant, when that is why it is called as determinant, it determines, it says, it tells us that the system has these many solutions, or it has one solution, or it has no solutions. So, that is why it is called as a determinant when you find that value. So, this determinant here is we have to consider this determinant to be like infinite solutions for the system of linear equations. That means, the det of this should be equal to 0. That is what we will take, and then we will calculate, try to find out the value of alpha, right. Let us see. So, the solutions, see the equations, I am writing the equations 1 times x plus x alpha y plus alpha square z. Next, alpha x plus y plus alpha z, this will be equal to -1. Then alpha square x plus alpha y plus z is equal to 1. So, those are the 3 equations which we have written here. We did not do anything, we just multiplied those 2 matrices and written there. We formed the equations from this system, we made these into linear equations, multiplying it, right. Now, the determinant of this should be equal to 0. The det of this should be equal to 0. I am taking the det to be 0. Most of you know how to calculate det, but for you just I will calculate it if you want. So, when I talk about this 1, so what do you have? 1 minus alpha square, right. You multiply these two and write it, and then minus alpha times, when you take this part and then this is to be removed, just give me a second, I will clear it for you. And when I am talking about this value, when I was on this, I have removed this column and this row. Now, when I am here, I will remove this column and this row. So, what I will have? Alpha minus alpha cube, and then if I take the other one, plus alpha square then I have to remove this and this, then it is alpha square minus alpha square. This is anyway 0. So, if you simplify this, you come to this point, 1 plus alpha power 4 minus alpha square, which is alpha power 4 minus 2 alpha square plus 1. Just rearrange the terms. Why did we rearrange? To get into the form of a square minus 2ab plus b square. A is here alpha square. So, to get into that form, we just rearrange the terms and then we wrote it into this formula, a minus b whole square, and it is already equal to 0. Why are we taking it 0? Because in the question it is given that it has infinitely many solutions. That is the reason we are equating it to 0 straight away. Clear? Now, alpha square will be equal to 1 and alpha is equal to plus 1 or minus 1. So, from this what did we get? Alpha is either plus 1 or minus 1. Now, we have to check for what values of alpha this will have unique, infinitely many, means there are 2 values now, right. So, both the values may be having at both the values of alpha, it may be having unique solution, infinitely many solutions or no solution. So, we will see how these equations are behaving at these 2 values, like alpha is equal to 1 and alpha is equal to minus 1. If alpha is 1, if I take the first value alpha is 1, what happens to these equations? Alpha is 1, then the system of equations will become x plus y plus z is equal to 1. And if I take the next one, x plus y plus z is equal to minus 1. And then if I substitute in the third equation, I get x plus y plus z is equal to 1. If you look at this, these two lines are planes, they are the exactly the same lines, they coincide with each other, they sit on each other. But this one is a line or a plane which is parallel to the other line or other, these are not two different lines, actually you can treat them as two coinciding lines, but it is the same line. This is a line which is parallel to that, right. So, when you have, and one more line on this, maybe how many solutions you can have between these two, they are not, they have no common point between them, right. So, there is no solution here, actually there are no solutions at all for that system of linear equations when alpha is equal to 1. Then when alpha is equal to minus 1, if you put alpha is equal to minus 1, alpha is equal to minus 1, then I have x minus y plus z, because alpha square becomes plus 1 again, which is equal to 1. And the second equation, if I substitute, that is minus x plus y minus z is equal to minus 1. If you multiply this equation with the minus sign on both sides, you get x minus y and plus z is equal to 1. That means this equation and this equation, these two equations are the same. That means this is nothing but this one, right. So, the first two equations we have got them as the same equations, and let us take the next one where x, because alpha square is minus 1 plus so this will be minus y, I am sorry, because alpha is minus, we need minus y and plus z, this is equal to 1. So, in this case we got all the three equations, when alpha is minus 1 we got all the three equations are the same, means they are all coinciding lines, like lines or planes, whatever they are coinciding with each other. So, this system will have this system of equations will have infinitely many solutions when alpha is equal to minus 1. So, if alpha is equal to minus 1, we have the system with infinitely many solutions. So, what is he asking us to find here? Find the value of 1 plus alpha square. So, what can we do here? 1 plus alpha is minus 1 plus minus 1 square. So, this value is equal to, this is 0, so 1. So, when this system has infinitely many solutions, the value of 1 plus alpha square should be equal to 1, and that is at alpha is equal to minus 1, right. Clear? Now, let us go to our next question. Yeah. So, here P is a matrix, a 3 by 3 matrix given to us. P is a 3 by 3 matrix which has alpha, an unknown value in it, and where A belongs to R. So, alpha is a real number, and suppose that Q is another matrix, Qij, Qij is a matrix such that PQ is equal to K. So, he is saying P and Q, the multiplication of PQ is possible, and Ki he is saying I is an identity matrix and K is a real number, it is a number, and I is the identity matrix, you all know 1 0 0 0 1 0 and 0 0 1 of order 3. That means Q also should be a matrix of order 3 by 3. If Q23 I am sorry Q23 is if this is a matrix Q, 2 3 2 comma 3 is the second row and third element, second row and third element of it is given by minus k by 8. So, this value he is saying is minus k by 8, and determinant of Q is given by k square by 2. If you find the determinant of that matrix, its value is k square by 2. Then he is asking us to check which of these are true. One is alpha is 0 and k is 8, or 4 alpha minus k plus 8 is equal to 0, or determinant of P times adjoint matrix of Q is equal to 2 power 9, or determinant of Q times adjoint P is equal to 2 power 13. So, we have to check which of these are true in this matrix, right. Right. So, we will start by taking this one, like PQ is equal to k times I, it is an identity matrix. So, k into I, k is a real number, right. Let us see what we can do here. So, I am starting with taking PQ is equal to ki, PQ is equal to ki, I is the identity matrix. Then what can we write? Q is equal to k times P inverse, inverse matrix of P. When he says PQ is equal to ki, then P is invertible matrix, right. If it is not invertible, then there won't be an identity matrix existing there. So, k into P inverse. What is P inverse? P inverse is nothing but the adjoint matrix of P by determinant of P, that we know, right. Like a matrix inverse, inverse of A is adjoint A by det A, right. So, using that, I am writing it as adjoint P by det of P. Now, k times det T, what is determinant of P here? If you calculate the determinant of P, let me calculate it here, I am writing it here, is equal to 3 times, you all know how to calculate, right, 3 times 0 plus so 3 times 0 plus 5 alpha minus 1 times 0 minus 3 alpha and plus 2 times minus 10, right. So, if you simplify that, is 15 alpha, and this is minus 3 alpha, 15 minus 3 is 12 alpha, right, 12 alpha, and minus of this is minus 2 outside. So, minus of minus 2 will be 20. So, plus 20. So, 12 alpha plus 20 will be the determinant of it. So, 12 alpha plus 20 will be the determinant. When you calculate it, like 3 times, you know how to write, like when you are doing with 3, take that minor. When you are taking 3, when you take 3, just take the minor, like this row and this column will be covered, and this is called as the minor there. You find that determinant of that value, and then when you take minus 1, see the signs also come alternate, like plus minus like that, right. When you take minus 1, close this, and then do the minor, means 2 alpha and 3 0 will come as the minus for you, minor elements for you, and when you take minus 2, then cover these two, and this will be the minor for you. And then when you do the determinant, you get 12 alpha plus 20. Now, adjoint of P, what is adjoint of P? Adjoint of P is nothing but the transpose of the cofactors of the matrix. What is the transpose of, what are the cofactors? Cofactors are nothing but the determinant values you take. For example, for 3, the cofactors of 3 will be this value, like the determinant of this value, right. 0 minus of minus plus 5 alpha would be the cofactor of the for the value corresponding to the value 3, and when you take minus 1, you cover this and this, that minor value will be the cofactor. Similarly, if I take 3, cover this and this, 3 alpha into minus 1 times 0 into minus 2. So, minus alpha will be your cofactor. So, once you write all the cofactors and transpose them, means change their rows to columns and columns to rows, then you will get your cofactor matrix. So, this is the cofactor matrix, like the first one is 5 alpha, right. So, 5 alpha, and then I interchange them. This is directly written as the adjoint matrix. This is the adjoint matrix we have. This is the transpose of the cofactors, right. So, you get these values. Okay. If you have any question, if you want me to find out the cofactors and find the adjoint matrix, then just give a comment in there, then I'll do it. It's a little bit lengthy process. In the short time we might not be able to cover, but I will do it for you if you need. This is the adjoint matrix, right. Next, what is given to us in the question? It is given that second row third column's element is equal to minus k by 8. So, in this is the element, right. So, this is the element, second row and third, and it is multiplying with this. So, minus k by 8 is equal to this times that. So, I am taking that element equal to minus k by 8, and if you do the simple algebra, if you calculate them, like if you multiply and simplify the terms, you get alpha equal, because you can cancel this k and k here, right, and then regroup the terms, and then if you calculate, you get alpha is equal to minus 1. The value of alpha is minus 1. So, this case is failing because we do not have alpha is equal to 0, right. Alpha is minus 1, we got the value of alpha is minus 1. So, this can be ruled out, right. Let us check for the remaining. So, alpha is minus 1. Then what can we do? We can find the value of k also to check if this is holding true, right. So, let us try doing that. Then what else is given to us? Q, determinant of q is equal to k square by 2. So, we will use that now. This is the value of q, and determinant of q. I am trying to find the determinant of q. You know, we just tried, right, taking this, find out. So, using that using the 3 by 3 matrix determinant rule, you can find the determinant of the matrix, which is equal to 120. See, this one and this one is 1 minus 5 times. It is written clearly for you here, 10 times 2 times 6 and 12 times minus 1. This I am taking, so I will rule these two out, right. Then you get this. When you take this, you rule this and this out, then you get this, and then this one, right. So, when you simplify, you get this value is equal to says 160 minus 120 is 40, so 64. This is 64. So, here 8 times 8 and 64 can be cancelled. So, that is the reason you got 1 by 2 is equal to k by 8. So, you can simply say k is equal to 4. So, I got k is equal to 4 and alpha is equal to minus 1. If I go back here, what do we get? K is equal to 4 and alpha is equal to minus 1. So, this is 4 and this is minus 1. So, minus 1 means minus 4 and minus 4. Minus 4 minus 4 is minus 8. Minus 8 plus 8 is equal to 0. So, this is one of the correct answers. One is B is one right answer for us. Now, let us check if any one of these two is the correct answer for the question. Now, what are we trying to find here? Determinant of P times adjoint Q. Determinant of P times adjoint Q, and then we will try to find determinant of Q times adjoint P, which is right. So, determinant of P times adjoint Q. So, what is this determinant of P times adjoint Q? I am writing P times adjoint of Q. What is Q here? Q is nothing but K times P inverse. K times P inverse. And what is the value of K we got? We got the value of K as 4. So, I can write this as 4 times P inverse. So, here I will write it as 4 times P inverse. Next, adjoint of k times A. If a matrix A is there and you are trying to find the adjoint of k times A, then it is nothing but k power n minus 1 times adjoint A. Why? Because adjoint of k times A, this can be written as k power n minus 1 times adjoint A, and n is the order of the matrix. So, here this for this I can write it as 4 power n minus 1, n is the order of P here is 3. So, 3 minus 1 is 2. So, 4 power 2 which is 16. So, that is a scalar. So, I am writing it to the extreme left 16 P times adjoint P inverse, 16 P times adjoint P inverse. Next 16 P times adjoint P inverse. Adjoint P inverse is nothing but P by det P. Why? Because see, determinant of or else det of A inverse is equal to 1 by det A, right. Det of A inverse is 1 by det A, we know that, right. Then what is A inverse is equal to 1 by det A times adjoint A, right. Am I right? Right. Now, if I want to take A inverse in the place, I am replacing A with A inverse, then this will become A equals to 1 by determinant of A inverse times adjoint of A inverse. Now, 1 by determinant of A inverse is nothing but determinant of A. So, A is equal to determinant of A times adjoint A inverse. So, if I bring this one here, it becomes A by determinant of A. So, instead of adjoint P inverse, I am writing it as P divided by det P. Is that clear? So, 16 times P by det P. Now, since here see the value, this one is also, we know this one, det K times A is equal to k power n times det A, where n is the order of the matrix. So, 16 by this determinant of P is nothing but a value, it is a scalar. So, I can write these two out of the determinant by making them as the power of 3, because the order of the matrix P is 3. So, it becomes 16 cube by det P whole cube outside the matrix times det P square, which is det P into det P. And what is determinant of P we got? -12 alpha plus 20, where alpha is -1. So, 12 alpha, that will be -12 plus 20, which is equal to 8. So, det P is 8 here. So, what can I write here? 16 cube by det P, which is 8 cube into P square. P square is 8 square. So, what will this become? So, this can be written as 16 cube by, this is nothing but 8 cube times 8 times 8, because P square, det P square is det P into det P, which is 8 times 8. So, this one and this cube, or else 64 will go in this 8 times, which is equal to, this can be written as 2 power 4 whole cube times 2 power minus 3, because 8 is 2 power minus 3, because it is in the denominator, I am taking it to the numerator. This is equal 2 power 12 minus 3, which is equal to 2 power 9. So, we got the value equal to 2 power 9. So, here we have this B and C are our correct answers. I hope you understood the questions, how to solve them, and I think like we have